Hey there, gang. This video is going to take us through how we take an essential question or a big question that we use to launch the learning for a unit in any class, whether it's environmental science or in this case a chemistry class, and how we then identify key expectations that link to that question that would be covered in the process of students trying to answer that question. And we take those expectations and then plan the unit out. And the really important thing is plan for assessment. So understand what we specifically are going to expect the students to be able to show us, and create a system so that kids know where the target is and what they need to do. So our question that we developed in class is, what is the footprint of drinking from aluminum cans over a lifetime? We started with what's the footprint of drinking Coke or pop over a lifetime, and refined it a little bit because you go through other types of cans as well. And so now that we have that, we now have a focus of where we're going in the course. And I've used this question for chemistry classes and environmental science classes, and you can use similar type of questions, maybe not related to aluminum cans, maybe related to other parts of people's lifestyle, right? So what we can see here are all the expectations that I've identified that this type of question would go through, just from the chemistry unit. And what we're going to do is we're going to focus on one set of questions right here, quantities and chemical reactions, because I actually did a question, or I did a lesson with you guys on that. And so this curriculum right here, which I've copied and pasted, this is the foundation of the lesson that I took our class through, where we tried to quantify a carbon footprint, so amount of carbon dioxide. We used some of the research that you guys had amassed, and we did it to find a quantity of aluminum that we could start with. And then I took you guys through a lesson where I taught you the concepts of stoichiometry, which in a nutshell is just using real-world masses and balanced chemical equations to figure out unknown masses. So we knew, or we determined, through some assumptions that we would have to defend, of course, that we would need about 208,000 grams or 208 kilograms of aluminum just for all the aluminum cans we go through in a lifetime. And what we wanted to do is figure out how much carbon dioxide that would produce, because that's a carbon footprint. There's other footprints we also could research, but that was the main one. And so, I modeled how you go through this problem-solving process, and then we talked about some other chemical reactions that would need to take place in order to just run this one. These three chemical reactions could be the ones required to produce the electricity. And so if we could figure out how much electricity it would require to make all this aluminum, we could then plug those values in and try and determine how much, say, CH4, which is natural gas, or the C by itself is coal, or the C25O52, that would be oil. If we burnt these fuels, how much carbon dioxide would that produce in the process? And along the way, all these fuels have a little bit of sulfur, so we need to determine how much sulfur is in the fuels. And sulfur, we can't have sulfur mixing with oxygen, forming sulfur dioxide, and that going into the atmosphere, because that leads to acid rain. So we'd have to look at some more chemical reactions and determine, if we scrub this SO2 with calcium carbonate, which is a CaCO3, how much more carbon dioxide would we produce? And so again, if we go to the expectations, these expectations all revolve around learning how to solve problems like this. So this is a great question because it ties in really nicely with the skills that would be required to answer a question like this. So as a teacher, I need to determine how I'm going to design the unit and how it's going to flow, and very importantly, what am I expecting from my students. And so this is where I develop a planning page like the one you see right here. And it's real simple, very straightforward. The idea is that we want to take a look at what overall expectations we're covering in any unit that we're doing. Things might overlap multiple units as well. This is such a big question that I would cover pretty much the entire course, so I could break it up into parts of the study. But if we're just looking at quantities and chemical reactions, I have my overall expectations are really important. Again, these are what we should be evaluating students on at the end of the course or at the end of the unit. So my first step is to isolate all my expectations. So I go through and I do my research and I copy paste from the curriculum, and what I like to do is break up my expectations into chunks. Sometimes a set of expectations are good on their own, but other times a few expectations can actually be lumped together. And I would call something like this, I would call it like a learning block, that all these expectations are tied in and you can't do one without the others. And so, over a couple days or a week, we focus on these three things as we're developing, specific skills and understandings. And so I do this for the whole unit. So I've only done a few of these here just to illustrate what I would do, but I would break this down and I would have many different rows. After I get my expectations, my next step is to develop coherent, student-friendly learning goals. And the formula for developing a learning goal is actually quite simple. So we always start with we are learning to bit. So what are we learning? What are the key skills we are learning to do or learning about? All right. So you could say we are learning to or we are learning about, and then you have the focus of what you're doing. But there's got to be a reason for that. So we end it with so that we can, or something like in order to, and we want to use terms that help make the learning real for the students. So in this example, we are learning to analyze the chemistry behind industrial processes so we can determine the impact our lifestyle has on the environment. This is written in a way that the grade 11 students are going to understand, right? And sometimes you write learning goals and they're not super great and you have to go back and fix them, and that's okay. Too much focus, I think, is put on learning goals. We don't need to put that much focus on them. The real focus, of course, in a second, we'll go through is the success criteria, because that for students is the most important thing. They want to know what they're learning, but they need to really know how they can showcase their learning. So again, with the next one, we are learning to use the correct terms when solving for stoichiometric problems so that we can understand our thought process when solving problems. I use, this is a nice kind of, this is a learning goal that's almost identical for each unit, because in chemistry and science, whenever you have a unit of study, one of the key things is learning the terms for that, the vocabulary for that unit, and using terms properly so that we understand what everyone's saying. And if you take a look at this next one, so I've got 3 expectations here, and what I work to do is try and come up with a statement that encapsulates everything. So these 3 expectations involve solving problems, performing calculations, calculations based on mass or quantity of moles and molecules, and solving problems using things like percentage yield and limiting reagents. Now, we didn't cover those 2 terms in our little lesson, but they would have been coming up the next day if we continued, if you were part of my class. So again, we are learning to, in this case, calculate unknown quantities in balanced chemical equations. I throw that in there because that's an important thing I want kids to remember, is that right from the get-go, you can't do any of this unless you balance your chemical equations. Using mole ratios so that we can solve real-world problems involving industrial processes. Notice I'm using similar language to the other learning goals, and that I think is really important. So when we kind of when I map out with the students where we're going with this, and you know, my big question, I think lays it out nicely. All these things tie into it really well. So now for the meat and potatoes, I'm really adamant that the key focus is got to be on success criteria. All right, developing student-friendly success criteria that it's not exact. It's not. We have to be careful that we're not making our success criteria too checklisty. So just yes and no's. There has to be, you know, they have to be able to show you that they can do, they can fully complete this, or almost fully complete it, or partially complete it, right? So there has to be some variance into the degree of how well they've completed this. And so if we zoom in on actually this part right here, we can see how I sort of scaffold my success criteria. I can write and balance the chemical equations in lowest terms, coefficients. Now that's a skill. Some kids can do it really well, some kids struggle a little bit with it, so there's some variance in there, but that's the most important thing when we're going to start. You have to be able to do this first before you can do anything else. I can use the mass quantity and molar mass value for a species to calculate the moles of such species. So again, this is where I'm scaffolding, I'm building up the skills, and so I can lay these out sort of like a list for kids, and this is something that they can always go back to and say, okay, I can do that thing, but I struggle with this thing, right? And showing students these are the steps that we're going to take when solving these problems. This is what I'm going to be assessing you on. The students know what we're going to focus on, and then they can make plans to make improvements. The ones up here, this is sort of what we started to jump into, researching the processes involved in producing aluminum ore to metal. So some groups worked on this. Differentiating between refining and smelting, so that would probably be based on a lesson I would do with you. Collecting information from various sources to develop a real-world picture of the chemistry involved in producing aluminum. We did all that as part of our class. And so what I've done is I decided to take all of these success criteria and work them into an assessment form. And I've created with some colleagues in the province and in my board, I've created what I think is a real straightforward, simple system for assessing student understanding. And what I do is I create this simple chart. It's very easy to do, and it's a chart that I can track student progress throughout a unit, throughout the course. I can copy paste this onto a test or onto the actual assignment. I can make this into little strips and write all over it, or I can use something like OneNote, which is like an online binder, and students can show me that they've met these success criteria using lots of different ways, and it doesn't matter which way they do it, they just need to show me that they can do these things. So I start with my learning goal. In this case, I put two of them together. So we're learning to analyze the chemistry behind industrial process so we can determine the impact our lifestyle has on the environment. We're learning to use correct terms when solving for stoichiometric problems so that we can understand our thought process when solving problems. So I'm going to group these two together. And then all I do is I copy paste the success criteria into the chart. That's all I do. Very, very, very straightforward. So once you've done your planning for a unit, you're just copying and pasting into an assessment form, and it doesn't take much time at all. And these things, students can show a degree of completion. And what I use is assessment form up here. C stands for complete. AC stands for almost complete, and P stands for partial. So they can, I can research the process involved in producing aluminum from ore to metal. Most of you are going to be able to show a complete ability to do that. Some of you might not quite have made it there, so it might be you might have missed some things, and so I would maybe say, okay, you've shown an almost complete ability to do that, and you would go back to your notes and say, okay, well, this is what the feedback on the work that we did, but overall, this is where I'm at. Differentiating between refining and smelting, maybe you nailed that completely. All right, you had no problem with that at all. Showed a complete understanding, complete explanations. Collecting information from various sources to develop a real-world picture, maybe you were lacking in that. So you really only focused on one aspect, and so you only showed a partial understanding of that. And maybe you're really stuck with the chemical equations. Maybe you hadn't gotten to that point yet. And so you're not there yet. And so I gave you this feedback, and then you went back and you did some more work. And then you were able to show me a couple days later that you were able to do this. So then I go back and say, okay, well, you went back and got some more research done, and you really showed me a complete real-world picture of all the different processes, all the different chemical processes involved in refining and smelting. Awesome. You broke all that down. You used your peers. You're able to show me that. And we had a conversation about it, so I know you know it. And then you... and so because of that, you also were able to identify some key footprints. So you were able to do a carbon footprint and an ecological footprint, but you still weren't able to show me water footprints. So I'm going to move this up to an almost complete. All right, you still need to be able to look at an equation and find water footprints there. So using a system like this allows kids to know what they can improve on, and if they've made movement on anything. And what I do at the end is I create certain values when we have to come up with a numeric mark. So anything that is a complete, I would give a 5 for. And anything that's almost complete, I would give a 4. And anything that's a partial, I give a 3. All right, and you, of course, you can make a 4 a 4.5, or a 3 a 3.5, or a 2.5. You can mess with the numbers a little bit, right? Because it's always a little bit fuzzy area in there. So, if I were to assess this student at this point, and their terms were pretty good, they would have 10 points for there. They would have 12 points for here, and that would be their score. So out of 5, 10, 15, 20, 25, they have 22 out of 25. All right, so 88%, and they know what they could work on, right? The two areas that they're sort of lacking. So I really like using this system. I know my students have really liked it too. If the students ever go home, show that parents are like, well, where are you good at? Where are you not good at? Because a lot of times they just see marks and they don't know where they come from. They can actually see where they're at, and then it gives students the ability to kind of argue and say, well, actually, no, I think I've shown that I can do this right here. And I love it when students advocate for themselves. And if they need a tutor, the tutor knows exactly what they're strong at and what they're weak at. And so a system like this, again, very straightforward. The big work comes right here, your planning chart. And so this is going to it takes time to do this, and it forces you to understand your expectations. But it will definitely pay dividends. Because as you go through and you teach a course more and more, you get better and better at it. You might change up some of the success criteria a little bit, but that's okay. It's always, your wording in that is always a work in progress. Okay, so I hope you enjoyed this video. I hope it allows you to get rolling and sort of see a process that you can use for planning a unit, including how you would develop your assessment schemes for that unit.